Hi guys, welcome to DBT Data Build Tool online training demo session. In this session, we are going to know what is DBT, what is DBT project, where exactly DBT fits in our data architecture, and we are going to know how DBT is special by looking at the capabilities of this tool. And I am going to display an architecture where DBT is playing a vital role in data engineering projects. And at the end of this session, I am going to display the syllabus, what we are covering as part of this course. Now let's go to understand what is DBT. DBT is an open source and it is written in Python. It helps us to templatize our ETLs. That is why I am using a term here, templatizing. Here, understanding the word templatizing is essential to understand DBT better. In data warehousing lifecycle, we have 4 core layers. They are loading the data from source to landing tables, and loading the data from landing to core tables, and loading the data from core tables to aggregate tables, and creating some reporting views on top of aggregate tables. And the 4th layer is reporting layer, where various kinds of reporting tools consume the data which you have populated in core and aggregate tables by using reporting views. Ultimately, DBT helps us to automate these 2 steps. Populating the data from landing table to core tables and populating aggregates and in creating reporting views. Why DBT is covering only these 2 steps? Why not step 1 and step 4? Basically, loading the data from source to landing tables varies based on the source you are using. If you are using Oracle as a source, flat files as a source, RDS as a source, Fivetran as a source, or files on the blob storage as a source. See, this layer is depending on the type of source you have to ingest the data in your warehouse. And let's take layer 2 and layer 3. These are irrespective of the source. Every company has similar mechanism to use in this step number 2 and step number 3. To perform these steps, companies use Informatica, DataStage, Amazon Glue, Matillion, native SQL of their data warehouse database like BTQ scripts in case of Teradata, SnowSQL scripts in case of Snowflake, and etc. When you brought DBT in your architecture, you can use SQL and small portion of Jinja scripting. You can make generic scripts. And if for one or more tables, generic script is not working, you have option to create table specific ETL script. Even in that, you can parameterize lot of things. So, you can make semi-generic ETL script. If you take layer 2, loading the data from landing table to core table, most of the time is not common. For some tables, it will be delete and insert. The tables which are having snapshot data will be continuously appending to the table. Or we will be doing CDC, change data capture. Like if we get the existing record, we need to capture the change. If we get new record, we need to insert that record into the core table. Not only this, loading from landing to core tables is not straightforward. You may need to standardize. Standardizing in terms of column names and in terms of values in the columns, you may need to apply some string functions. You may have some calculations for derived columns, or you may need to join with some of the dimension tables, or you may need to refer some lookup tables to load the data into core tables. If you look at the layer number 3, we are having almost similar operations what we have in layer number 2. That is applying transformations, applying rules, filter conditions, case statements, aggregations. And always our target may not be a table. There is a necessity where we need to create a view on top of our landing table. There is a necessity where we are creating a view. In that view definition, we have some calculation. Wherever you have the necessity to apply the transformations and populate your core or aggregate tables, that's where the DBT exactly fits in. To understand this term templatizing, the simplest example I can give is, think that if you want to delete the data before loading the tables, you can make a template where the table name is parameterized and condition also parameterized. Where condition. You can use that script to delete the data from any table which you pass during the runtime. Think this way, you are not going to have delete statement in the first place of your ETL scripts, right? If you extrapolate this idea, you can templatize anything where you are doing transformations. Okay, let's go to our notes. In DBT, we are using select statements and some simple Jinja script. When you are adding Jinja scripting along with your SQLs, it brings the power of programming environment. Jinja scripting is very easy as it is a wrapper on top of Python. And the beauty in DBT is whatever the generic scripts or whatever the scripts you are preparing, DBT is automatically recording the dependencies between the scripts, so that you will get an option to run the entire pipeline or some part of the pipeline based on your need. Isn't it interesting? Here is the diagram to show you whatever we have discussed in the picture format. So this is the source layer, and we are using source specific data loaders, and we are bringing that raw data from the sources into our data warehouse. Once you brought the raw data, then we have DBT in action. It can perform all kind of transformations and load into your core and aggregate tables, and it can make the reporting views. And then those reporting views will be consumed by BA tools, or the data in the aggregate or core tables can be consumed by the analytics teams. Next, let's try to understand what is DBT project. We can say it is a folder. Inside that we have arrangement of folders and the files required, where you use those folders and files to write your code and specify the configurations is called a DBT project. So to work with DBT, what we need is a home directory for your ETL work, and you need DBT software. As DBT is developed on Python, we can install DBT software using pip install command. That is the first prerequisite. And then create a home directory where you wish to have all your ETL work. Like when you are working with Data Stage, Informatica or any other tool, we usually have arrangement of folders like temp directory, source directory, targets directory, scripts directory, directory for rejected records, log directory, something like that. In the similar way, we have to have a directory for DBT. So I am creating a folder cdw_home, and I went into that folder. Now the next task is we need to initialize a project. How to initialize? Here initialize in the sense the DBT is automatically creating the required folder structures and mandatorily required files there. After you initialize, meaning after the infrastructure gets created in the home directory, next is your turn. You need to write the SQLs and specify the configurations to make the templates. Okay, so what I did here, that is initializing a project. So I am giving my project name as CDW. When I run this command, a CDW folder will be created automatically. And once you get into that folder, check what is inside. You see, these are the folders by default gets created. And not only this, when you are working with DBT, you may need to create folders based on the features you want in your ETLs. These are the folders. And this is the configuration file that DBT is giving upfront. So this will be your starting point to use DBT. Okay, as you are new to DBT, you may ask, what are the files and folders at least we need to make a template for an ETL script? Answer to that question is, we need these three files. One SQL file, one dbt_project.ml, profiles.ml file. This SQL file should be under models folder. In that SQL file, you are going to write a single select command. In that select command, you are specifying transformations, whatever you want. And you are specifying there in that SQL file, do you want a view for the query you have written? Or you want to create a table with the result of the query that you have written? Or you already have the table and you want to append the result of your select query into the table? Or you already have a table and now you want to perform the CDC on the table with the data what you are getting from your select statement. Okay, you will choose one of the options. Now dbt_projects.ml. This is the mandatory file where you are going to define your project, or you can say about your task, like which column can be not null column, or which is unique column, or you can specify if you want to refer a column which is in different table like foreign key. And not only this, if you want to run any post or pre-session commands, you can specify here. And the third one is profiles.ml. This is where you are specifying your data warehouse connections. For example, in case of Snowflake, your Snowflake account string, username and password of the DBT user. We need to define the role, the database and schema your project to use. And here the schema database names you can override later. But essentially what we need in this profiles.ml file is your database connection string login credential. And once you define, now we need to run this SQL file. Whatever you have specified, that action will be performed. How to run that SQL script? Using the following command. dbt run -m, m stands for model, and give your SQL file name, that is dbt.sql. If you look at here, what this model doing is, it is creating a department table in this database and in this schema, and populating this table from the result of the select statement which you have specified in this file. Let us summarize. Now we know what is DBT project and what are the least infrastructure we need to run a ETL. We need 4 things to run an ETL. One is SQL file. The second one is to specify the table properties. We need dbt_projects.ml and profiles.ml file to specify our data warehouse connections, and we need dbt run command to run our defined SQL. Next, now let's talk something about DBT features, how it can help in our ETL's implementation. DBT is a tool. It helps us to develop generic transformation logic, including CDCs, auto-designing the data pipelines, and it has tight integration with versioning and CICD tools. Like you can integrate DBT with GitHub, and you can run your scripts from your on-premise and you can run on the cloud, because DBT has cloud version of it. Based on the need of your company, you can use DBT in on-premise or you can use DBT cloud version. And DBT performs checks on the source data to checking the data in the aggregates with the custom tests, or there are some built-in tests before you are presenting the data to your executives. And another beautiful feature in DBT is auto documentation. You don't need to deal documentation of your ETLs as a different task. Documenting in the sense the description of the column, description of the table, or dependencies, or definition of a particular KPI. You don't need to take this as a separate task. You go and implementing your ETLs, so automatically captures the descriptions or the comments that you have given in your templates, and the dependencies and the constraints on the columns you have applied. All this information it gathers and it will make a GUI for you, and you can share this with your teams. And DBT provides features like hooks, means you can perform some action after you perform the ETL or before performing the ETL, that we generally call pre-session and post-session commands. And another excellent feature is it is very easy to manage the environment, development environment, production environment, UAT. It is very easy to maintain these environments and switching from one environment to another. So much power in our hand in the form of DBT for your ETLs. How you are going to use it, that depends upon your expertise. To let you get more understanding on templatization of ETL scripts, let's go through a demo exercise so that you will clearly understand the concepts going forward. Let us look at here. This is an ETL template. What it does is it inserts the incremental data into this particular table from this table based on the condition where source record timestamp is greater than maximum date we have in the target table. Can you please observe here? Is anywhere either a database name or table name is specified? No, right? Since this script is not belongs to a particular table, we can call it as a template for incremental loads. Let's check how it is going to work. Let me jump on to Snowflake web interface. In this exercise, I am taking 2 tables. One is source table, the second one is the target table. In Snowflake, source table and target table, these 2 tables are residing in 2 different schemas. Currently, both the tables are empty. Let me insert a record in source table. I see one record is inserted. Let's check that. Yes, new record is inserted. Now we have target table empty. That's why I am inserting a dummy record, because in our script I am trying to get maximum load date. Let's check for dummy record. Yes, we got the dummy record. Let us run our template which we have created for incremental loading. To run that template, following is the command. dbt run -m stands for model. This is our template name, tmpl underscore incremental, and this is source table name, and this is my target table name. The database and schema names of target table I have defined in profiles.aml file. Okay, let's give a hit here. Script is finished. Let's check the results. Select star from target table. Now I see a new record inserted. Now in this cycle, let's insert a new record in source table with the department number 20. Let's go back to our shell, rerun our command. Yep, it looks finished. Let's check the result. We see here new record is appended to our target table. Isn't it awesome? I'm sure that this skill increase the value of your profile, irrespective whether you are working on Redshift, BigQuery, Teradata, or on Snowflake. DBT works on all these platforms. Alright, let's continue. Now let's take a look at important features of DBT. The first one is Materializations. As I said, in DBT, we write a single select SQL statement. That select statement takes different forms, depends upon the materialization you specify. There are 4 kinds of materializations exist in DBT. They are view, table, ephemeral, and incremental. When you specify view, DBT creates a view with the columns you have specified in your select statement. If you specify materialization as table, what DBT does is it creates a table and populates that table with the result of the select query you have given. Third one is ephemeral. It means DBT creates a named subquery. Later, you can use that named subquery wherever you want. It is very much helpful for templatizing our ETLs. And the next one is incremental. In this case, what DBT does is first time it creates a table and populates that table with the result of the select query you have given. From the next time onwards, it will be continuously appending the data to the table. Basically, this kind of mechanism will work when you are loading daily snapshot data into the tables. Using this materialization, we can implement CDC instead of appending all the records into the table. The next one is dependencies. As I said previously, DBT automatically keeps track of dependency between the ETLs based on which table first you are populating and based on the references you are specifying in our ETLs, DBT automatically creating dependencies graph that is called DAG. The benefit of this is when you run the project, DBT knows the sequence of tables it should populate. This helps us not to spend the time working on the dependencies whenever we are bringing new table into the pipeline. DBT gives an opportunity to run a portion of the DAG. The next feature is DBT offers code compiler. As I said, in DBT, ETL scripts comprised of SQL commands and few lines of Jinja scripting. So this combination helps us to implement the control structures in our queries. Not only that, using this combination, we can create reusable code that we are calling in DBT as macros. Let's say macros are not more than our functions in programming language. Next, documentation. DBT has the capability of auto-documenting the things. See, when we are creating an ETL template, we will be writing comments wherever we are performing the joins or the purpose of template. And if you add some filters in that select command, you will be specifying why you are adding these filter commands. All this automatically DBT cap, and these comments are presented in the form of web GUI with hyperlinks, etc. etc. And later we can share this with our teams. In the next, testing. DBT gives an opportunity not only implementation of ETL scripts. Furthermore, we can perform data validation starting from source data to our aggregate tables. The data validation starting from nullability check, dupes, uniqueness, in a given column. Starting from those built-in tests, you can write SQLs to perform the custom testing, where you are comparing today's data with previous days of data to make sure today's data is in pattern, and custom tests like to check whether is there any missing data. This helps a lot to gain the trust of your executives or end users. And DBT gives an opportunity. You can run these tests along with the project or separately. And the next one is seed files. This concept is equal to lookup data files in case of other ETL tools. These lookup files helps us to have referential data, like we have country short code and its long description, or product class and its descriptions. So the data which we frequently use, that we can maintain in a CSV file, and then we can use it in DBT, so that you are minimizing burden on the database. The concept snapshots we are applying on those tables on which we want to apply CDC, especially type 2. When you apply the snapshot on a table, when DBT is running, it compares the data in the table versus the data it is loading from, and it performs the CDC. To recognize which is the current record and which is past one, DBT maintains record begin date and end dates. The next feature is exposures. This is one of the beautiful feature in DBT. See, in general, company can have multiple reporting environments. Think some projects data is reporting through MicroStrategy. Some of the end users are using Tableau. A percentage of user groups are using Cognos reports. When you are working with the aggregates, you can specify which reporting system is going to use that aggregate, so that if there is a necessity to rerun your MicroStrategy reports with the refreshed data, what you can do is you can run only those ETLs which are specified with exposures is equal to MicroStrategy. See, note here, this time you are not running the ETLs with the ETL names, but in the context of end user. I say this is an excellent feature. And next feature is macros and Jinja scripting. Jinja scripting with SQL gives the power of programming environment for SQL. This programming environment was possible only with PLSQL or SQL with some programming language combination like Java, JavaScript. Since Jinja is developed on Python, Jinja scripting is very easy than JavaScript. Using Jinja scripting, you will be able to read the environment variables of your system. Not only that, you can execute your OS commands when you use Jinja scripting. That helps in doing many things like sending an email after completion of a stats job, or sending notification emails, or performing some shell commands during your ETL based on the problem in hand. Next, hooks. Hooks is a portion of SQL which you want to run beginning or end of your ETL script's execution. For example, you want to delete records from your table before loading today's delta. This situation comes when there is a necessity where you are running your ETL scripts multiple times in the same day. This is a small example, but these are the facilities DBT is giving. We can use based on the situation. This concept hooks we can call alternatively as pre-session and post-session commands. Next feature is operations. This feature helps us to run a macro separately. As I said, macro is reusable code which you can call wherever you want in your data pipelines. Generally, macros will be called through your ETL script, but the feature operations is helping us to run macros separately. Suppose take a situation, you want to load a temporary table because that temporary table is using in many data pipelines. So to populate this temporary table, you have written a macro. So you will make sure that before running your data pipelines, you will be running the command which is highlighted here, so that the macro grant_select runs separately. Next, packages. See, in Python how we have packages. So you can call some functionality which is outside of your ETL script. By calling that package, you will get that functionality in the current ETL script. It means DBT is giving facility to us to modularize our scripts. Next, analysis. Now, you know that ETL script in DBT looks like a template with table name parameterized, conditions parameterized, subqueries parameterized, and so on. Suppose I want to get its SQL query, so that I want to run that SQL on the database directly. Or the query which is in DBT, I want to run that on Cognos. As it is, it will not work there, right? That's why DBT has given a feature called analysis. When you use this feature, what happens is DBT compiles your ETL script and produces the select statement, and then you can use that select SQL statements in other tools, or you can run on your target database if you want to debug further in that query. Next, metrics. This is one of the awesome feature. The intention of this feature is maintain the versions of a given KPI. Suppose we are having a KPI, sales revenue. Your business teams define that sales revenue KPI with some exclusions, inclusions, and with some calculations. Later they want some change in that. They want to include revenue generating from some source X. So far what we are doing, we are having the current definition of the metric. We are maintaining current definition of our metric or KPI. If you want to maintain the versions, there is a manual effort required. When you use DBT, you can specify to which KPIs you want to maintain the versioning, so that whenever there are changes on the rules of that KPI, DBT maintains the versions. More than that, it auto-document these versions so that we can refer any point of time and we can share with our business users. Now let's talk about some high-level architecture of data engineering project where we have DBT as one of the key member. These are the sources. This is our reporting stack, and this is our target, meaning our data warehouse. This is our ETL server. Previously we used to use Informatica data stage. Since DBT is in place, so this is the ETL server where DBT installed. In this server, we are maintaining all our DBT projects, meaning all our project folders and their corresponding ETLs will present in this server. And there are some tools like Git for maintaining the versions of our ETL scripts. Think that he's a data engineer. Once he get into this environment, what he need to do is he need to install DBT desktop version in his machine and get the latest code from the Git. And based on the task, he will work on those ETL scripts. During the development, he may need to execute his ETL scripts. So in this case, since he has DBT locally, whatever the queries that ETL script has gets executed on the target data warehouse. So once he is satisfied with his development, he can push his changes to the Git. Once the latest version is committed in the Git, so somehow we need to copy the latest scripts from the Git server to our ETL server. There will be manual effort to copy the latest scripts from Git to your DBT server, or we can say to your ETL server. You know, DBT has its cloud version where all the changes are getting committed on GitHub, and there is an integration between GitHub and DBT Cloud. In the cloud version of DBT, we have inbuilt scheduler, and since it is integrated with GitHub, so DBT Cloud automatically takes the latest code from the Git and use it during the execution of data pipelines. I hope now you understood what is DBT and how it works and what are the features that DBT has and high-level architecture of data engineering project when DBT is in action. Now let's have a look at the syllabus which we are covering as part of this training program. Throughout the course, when we are discussing about a concept, we discuss by taking a real-time example. So that way, things will be more understandable. If you are interested to take this course, please contact us on the given numbers. Thank you for your time for watching this video. And please don't forget to subscribe this channel. Thank you and take care.